How does a nuclear reactor work? Nuclear reactors are, fundamentally, large kettles, which are used to heat water to produce enormous amounts of low-carbon electricity. They come in different sizes and shapes, and can be powered by a variety of different fuels. A nuclear reactor is driven by the splitting of atoms, a process called fission, where a particle is fired at an atom, which then fissions into two smaller atoms and some additional neutrons. Some of the neutrons that are released then hit other atoms, causing them to fission too and release more neutrons. This is called a chain reaction. The fissioning of atoms in the chain reaction also releases a large amount of energy as heat. The generated heat is removed from the reactor by a circulating fluid, typically water. This heat can then be used to generate steam, which drives turbines for electricity production. In order to ensure the nuclear reaction takes place at the right speed, reactors have systems that accelerate, slow, or shut down the nuclear reaction and the heat it produces. This is normally done with control rods, which typically are made out of neutron-absorbing materials such as silver and boron. Nuclear reactors come in many different shapes and sizes. Some use water to cool their cores, whilst others use gas or liquid metal. The most common power reactor types use water, with more than 90% of the world's reactors being water-based. Further information on the many different types of reactor around the world can be found in the Nuclear Power Reactors section of the Information Library. Nuclear reactors are very reliable at generating electricity, capable of running for 24 hours a day for many months, if not years, without interruption, whatever the weather or season. Additionally, most nuclear reactors can operate for very long periods of time, over 60 years in many cases. In 2019, Units 3 and 4 at the Turkey Point plant in Florida were the first reactors in the world to be licensed for 80 years of operation. A number of different materials can be used to fuel a reactor, but most commonly uranium is used. Uranium is abundant, and can be found in many places around the world, including in the oceans. Other fuels, such as plutonium and thorium, can also be used. Most of today's reactors contain several hundred fuel assemblies, each having thousands of small pellets of uranium fuel. A single pellet contains as much energy as there is in 1 ton of coal. A typical reactor requires about 27 tons of fresh fuel each year. In contrast, a coal power station of a similar size would require more than 2.5 million tons of coal to produce as much electricity. Like any industry, the nuclear industry generates waste. However, unlike many industries, nuclear power generates very little of it, and fully contains and manages what it does produce. The vast majority of the waste from nuclear power plants is not very radioactive and for many decades has been responsibly managed and disposed of. If nuclear power was used to supply a person's electricity needs for an entire year, only about 5 grams of highly radioactive waste would be produced, which is the same weight as a sheet of paper. The used fuel which comes out of the reactor can be managed in different ways, including recycling for energy production or direct disposal. As a matter of fact, many countries have been using recycled fuel for decades to partially fuel their reactors.